Hi guys, so we're back again with another tutorial, another procedural effect tutorial in Unity, and let's see what we're gonna do. So today we're gonna be doing these slides with a sphere here. So as you can see, they're basically like if you got on a piece of cloth and you put it around the sphere. Actually, it's more like if you cut the sphere and you leave only a part there, and then you see that it depends a lot on the which one you get. We're gonna start first doing only the geometry, and later we'll do the textures, which may or may not end up looking like this, but we'll try to make it look as close as possible. So let's get on with that. This is gonna be okay. This is completely independent of these, so we're not gonna be modifying anymore the wire sphere tool, but we're gonna create a new tool to create these slices. So we're gonna create a new C# script, and we're gonna call sphere slice tool, for instance. Let's edit. Okay. This tool helps the user create sphere slices for the effect. Okay. It's gonna be we're gonna need Unity editor, and we're gonna use here editor window. Again, we want attributes here, and this is gonna be editor window methods, which are not actually editor window methods, most of them, but anyway. Okay. So here we are. So we're gonna copy a few things from here because why not? Like yeah, let's copy these and these. Got a sphere slice tool, and yeah, we need it on scene GUI. And well, at least we got the. We need to find the on GUI. Okay, so yeah, this part is basically almost the same, except for the fact that we need one sphere slice tool. We're gonna call it sphere slice tool. Yeah, sounds good. Basically, this is cool. We can now have a sphere slice tool, which it's just this. We can close it. Very good. Now let's start thinking about the attributes that we want here. So the first thing we want to have is definitely the radius. And we're gonna put it at 10. Then so this is a sphere with that radius. And then we want a minimum and a maximum pitch. Say, I don't know, 15. So yeah, let's do this for the time being. Okay, so in the on GUI, let's copy. I mean, there's no point in rewriting this code if you already have it there. So the radius is the same, and then the so these, so we get in this. So yeah, it's gonna be minimum pitch and maximum pitch. It's gonna be like that. Remove these, and they're gonna go from -90 to 90 degrees. Okay, so we can have negative degrees here too. And this call. Yep. So then you got a separator, and probably we're gonna be needing same things here. This part is gonna be probably the same. Yeah. And we're gonna be needing these 3 attributes exactly the same. Which brings us to a so we're gonna be doing this, right? This we have just copied and pasted some stuff, and at the end we go and again we do this, which is this. So instead of generate wire sphere, generate sphere slice. Exit, and then we create this private this method void generate sphere slice. So it is, as I said many times, I hate copying and pasting code. So if this is gonna be something that is gonna be shared between classes, it's most likely that we may want to do something about it. In our case, it requires some attributes, so maybe we can have a mesh editor window, a mesh generation editor window base class that derives from editor window and has these variables and these and a new method that does this. Yep, I think we can do that. Got all these and this seems cool. Let's see if we can let's call it wire sphere. We're not gonna give it wire sphere here. It's gonna be a different one. Sphere slice. This is even one of those things that we may want to change at the start. So we could, as I said, let's create a mesh editor window. Creation editor. So basically all these two are creating meshes that we're later using in our effect. So we're gonna be making them effectively childs of a custom class that has these some of these methods already available. Base class for the mesh generation windows. It includes some functionality common to all these editor tools and some shared attributes too. So again, we're gonna have attributes, properties, editor methods, and the methods. Okay, so first these, we're gonna be getting these, and instead of private, we're gonna make it protected. Okay, so we got this is our mesh name. So now we can drag from mesh creation editor window, and we can get rid of that. And so far it should be okay. So yeah, it looks like it's still working fine. Cool. So now let's we can also get these here, because really this is something we're sharing again. Instead of private, they can be protected virtual, so we can later override if you want. And same thing here. This is shared stuff that you don't want to do twice. You just want to do only once if you can. And finally, we're gonna create something like this. Just so something that writes this. Something that this is a protected static void. So GUI mesh info. So the UI widgets, the mesh name, the folder where to place it, and the default material, generating it in the scene. So here we go, we have this maybe we can leave the separator out, because this is something that you probably want to define yourself. Yeah. So if that's correct, we're still having the same results. Yeah, that's right. And the thing is, now we can do this for the wire sphere too. So we can get rid of these two, we don't need them, and this one can be protected, override. And in the GUI, we can go and get rid of all these and show GUI for mesh info, and it should be the same. Yep, changes now its mesh name, but the same is this. All right, great. That's good. That's good. We have that way. What we've done is we have avoided writing the code twice. We're just writing it once, and we are referencing it twice. It is a lot better to do that, because if you have an error, you only fix it once here. It also distributes the code in different classes, making the classes less big, which, you know, I mean, this is already 300 lines of code, so making it, and this function is relatively big, 60 lines of code or something, 40 or 50 lines of code. It's not huge, but it was before like 50 or 60, and making it a little bit smaller is always good. It's always nice. Definitely nothing wrong with it. It's going to make it easier to read and to follow. So with all that said, Um, let's get to implement the particular parts of this sphere slice tool. So now we have everything, the basic stuff, all the basic stuff that we need. We can start implementing it. Right now, we could even do the let's do the debug drawing. We're gonna make it in greenish blue, so something like a aquamarina. And we're gonna do so float y is gonna be sine of math f vector rad times min pitch rad is gonna be this. Okay, min pitch rads, and this is times the radius. This is the radius, but it's going to be the cosine. So this is, so it's going to be min pitch y, min pitch radius, and same for the max. Now we can do the debug rendering and move these here. Our handles, our wire arc at good. So in order to see it better, we are gonna be hiding this. So yeah, there we see. Okay, good. Now, so we have some indication of where it goes, more or less. Now, let's go with the geometry generation method. This is even something where we can have some stuff common in between these two tools. Maybe it's something we should do too. So for instance, creating the object in the scene is something that we can share. Even make it virtual, so you can change it if you want, and do something else on top of this. But it's virtual and it's the game object, and it's something that you can do. And yeah, the rest is this is very ad hoc, and this is very ad hoc too. This is just generating the wire mesh, and the one is the balls. So yeah, it's not gonna be very different. We could have these as a function too, which, well, why not? It's so yeah, we could take these as a small function. It's relatively simple. And again, make it visual too, just in case someone wants to override it. Oh, mesh name is not, it's just extension. Extensions again are something that we're gonna be there's the given mesh as an asset in the asset database. So extension is gonna be again shared. We're gonna actually rename it to extension with a capital E, and path is gonna be so yeah, now this makes sense. Oh, wiresphere tool doesn't need this, and we can do save asset plus asset, and we just pass the asset. That's it. Well, maybe we want to do this too and return it. So nice. Just to make sure, yeah. That seems all right. So yeah, it simplifies a little bit the code here. It's obvious, and yeah, we've taken some of the complexity to a base class, which makes it simpler. So now the sphere slice tool has this function which is going to be very similar to the one we have in the wire sphere tool. So in here we have these three options. So we create sphere slice, then save mesh asset, and create object, and mesh object in the scene. The create mesh object in the scene is also something that we are sharing. So yeah, this is the only thing that is new. We're not gonna be generating a bunch of nodes here. So we just create this function, which is gonna return a mesh. Cool. So yeah, so far so good. Let's in here this is just the initial part is going to be very similar, and we're going to be copying it, although the number of nodes is going to be different. So the number of vertices, and so again, so we need the steps. So again, we're going to be needing private static int num page steps, I don't know, 10, private static and num your steps. For instance, we're gonna copy these two. So this is very similar, but this is complete. This is similar, but it's so the number of steps and so on is similar, but we're not going to be reusing this because this is really very ad hoc to this slice generation. Actually, later we're going to be changing these pitch, min and max pitch based on some different criteria we will define later. So the number of vertices. How many vertices do we want? Well, we want the number of steps times in the pitch times the number of steps in the job. This is the number of vertices that we want. So how many indices? So the way we're going to be doing this is we're going to be doing the number of indices is something that we're going to be we don't want the notes, by the way. So number of indices is we're gonna be defining the triangles as bands of polygons that are gonna go around. So we're gonna do a band in the first. We subdivide the we're gonna subdivide in bands that go from top to bottom or to bottom to top, and there's gonna be num your steps quads in every band because it goes around, and there's gonna be num pitch steps minus 1 bands because there's num pitch steps vertices, so that's gonna be 6 times num your steps times num pitch steps minus 1. That's the number of indices. Oh, here we go. We got the arrays of vertices and indices created. Now, let's iterate over pitch angle first. I pitch is 0. I pitch lower than num pitch steps plus I pitch. All right. So again, we're gonna be copying this first part because it's gonna be just the same. This is exactly the same. This is not, for the time being, it's exactly the same. We will change it later, okay? So, but instead of doing this, we're between min pitch and max pitch. So we interpolate between min pitch and max pitch with these, and then we calculate the y and the inner radius, and then for your is 0, your your steps plus your, and again we are going to be calculating this. This is going to be the same. Calculate the C position and X and C. This is exactly the same so far. Okay, and this generates a position, and the normal is gonna be actually that position normalized because we want it to look outwards, and the UV, that's gonna be a little bit different. So it's gonna be probably well, Well, it depends. So probably in order to do this with the proper UVs, we're gonna be needing more vertices. We're gonna be needing one more step and one more yaw step, because otherwise we cannot join together 0 and 1. So this is gonna be the same, but this is gonna be one more. So now TYO goes from 0 to 1 because this is the maximum values new yaw steps. So this is gonna be from 0 when IY is 0 to 1 when IY is num yaw steps. And that means TYO, it goes from 0 to 1, and T pitch goes from 0 to 1 too. So we can actually do a proper UV. So vertices is gonna be so index is gonna be IB times num yaw steps plus 1 plus IO. So index is gonna be pos, normals is gonna be post normalized, and UVs is gonna be a new vector 2, TYO, T pitch. Yeah. So this basically generates all the vertices. Oh, by the way, now we have to generate all the indices, but this, by the way, is going to be also shared. Okay. Now, again, we're going to be, well, as opposed to before where we had like nodes, here we're going to be iterating with the pitch, so, and the yaw. So IP is going to be that, IP lower than pitch steps minus 1, because we want to always have 1, plus IP, and for int IO is 0, IO yaw steps, because we have num yaw steps plus 1, IO. So base pitch index, base B index is gonna be base index is gonna be num pitch step, no, times IP. Next, base index is gonna be this times IP plus 1. And then we just use IY and IY plus 1. So base I index, so base index for the indices, this is for the vertices, okay? So let's put a V here, a V for the vertex, and the I index is gonna be 6 times IP times num pitch steps plus IO. So indices base I index plus 0 is gonna be base B index. Yeah. So we already defined the quad. So we got the quad, right? And now base B index plus IO. So the next one is going to be in the next, so base next the index plus IO plus 1. Well, let's see. And this one is going to be base B index plus IO plus 1. And again, same thing here, IO. Then it's going to be this. And it's going to be this. I think this is the right combination to generate the quads, but let's see if I haven't made a mistake. So the material, I'm just gonna give it the full material. We're gonna call it sphere slice 1. Wow, yeah, something went wrong. Sphere slice 1. Oh. Okay. So this is definitely not what I was expecting. Yep, I did something obviously very wrong. Let's see. I don't see what's wrong with this. I think this is the problem. Okay, good. So at least, well, it's not good. It's obviously not working, but it's at least showing something. So the first thing that is pretty obvious here is that some of the triangles are looking inwards. Don't know which ones. Let's try second triangle, and let's see if it's the right one. I always use the I try, and okay, I made a mistake, so I obviously did it wrong. So this one was right, this is the one that was now. That was inverted, and now if I write a sphere slice 1, full material goes with. Now it's looking better. But we have another problem, is that why is this only showing a quarter of the sphere, but in the top one it's showing the whole sphere. So let's see. This is kind of weird. Let's see. Oh, yeah. This is again same thing here. So let's delete these. Sphere slice 1 and give it the full material, and yeah, that's better. So this is correct. This is exactly what we were looking for, and yeah, we've got it working good. Yep. So if we and we create another slice, it creates a different slice, and yeah, and these guys these guys can actually rotate around the center of the sphere, which is exactly what we need. So yeah, very good. Looks like we have a generation of slices, but one of the things that we may notice is that these slices are not exactly like these sometimes, where you got this part and this part, they are parallel. These two circles are parallel. At least they live in planes that are parallel to each other. But if you think about it, this one is short. It's like there's a short distance here, and there is a bigger distance here. And even though part of that may be due to texture, a lot of it is not due to it. It's because these slices, these two planes, the planes that cut this sphere, they are not parallel. So we are going to have to change that. But we'll do it in the next video, because this one is already long enough. I hope you guys enjoyed it. If you like it, please hit the like button, and yeah, as usual, if you got any questions, write them in the comments, and I hope to see you guys in the next video. Bye.